raising a power to a power. So as we learn about more multiplication properties of exponents, it's important to understand, exponents are a shortcut in writing multiplication. For example, and this is going to be outside of the notes, but for example, if I have 2b to the 5th cubed, that is the same thing as 2 times 2 times 2, because that would be 2 cubed, times b to the 5th times b to the 5th times b to the 5th. So that just allows me to write it in a simplified fashion. And then in doing so, that would be 8b to the 15th, some of the properties that we've already learned. But understanding that exponents are just an abbreviated way of writing multiplication to make it a little bit easier on us. And we want to be able to understand the mathematics behind the exponential notation, and where we derive that to where it helps us understand a little bit easier on writing it. So we're going to gain that knowledge in multiplying exponential terms with the same base, raising exponential terms to a power, and then learning how to simplify them. So as we work with a power raised to a power, if we have n raised to the m power, that is going to be equivalent of a times n, or a raised to the n times m power, because we're going to multiply. When raising a power to a power, we multiply those powers or those exponents. And so what is the simplified form of each one of these expressions? Well, we have p to the 4th raised to the 5th power. And so that is going to be p to the 4th times, or p raised to the 4 times 5, which is p to the 20th. And if we break that down and we maybe do the expanded form to show it a little bit differently, that would be p to the 4th times 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 p to the 4th, right? Because that is p to the 4th 5 times. Now, when we were multiplying like bases, well, I have like bases. I have p, those are all like bases, and then when multiplying like bases, I add the exponents. So that would be p 4 plus 4 plus 4 plus 4 plus 4, which turns out to be p to the 20th. So if we did it out in the expanded form and then combined and then multiplied like bases, we would have had p to the 20th. So that sort of helps identify and prove that by multiplying a power raised to a power by multiplying the exponents, we get the same answer. So there we have it. So as we go on to b here, we have p to the 5th raised to the 4th, which would be b to the 5th times 4, which turns out to be the same answer, p to the 20th. Let's see here. Oh my gosh, we're going to multiply some fractions. And so we have p 1/2 raised to the 1/4. So we would multiply our exponents. So we would have p to the 1/8. And then it looks like we have the same problem. We have p to the 1/4 raised to the 1/2. And when multiplying that, we would have p to the 1/8. And of course, if you are thinking about it, why on earth are those the same answer? Well, when it comes to the commutative property of multiplication, order doesn't matter. You get the same result. Well, that's all that's happened here is we actually had a different order of the same numbers. So we would expect to have the same answer. Let's see. So as we go on, what is the simplified form of each expression? Okay, so knowing here, we have x squared times x to the 6 raised to the -4th power. Okay, so we know that this 2 goes to the x, this 6 goes to this x, and this -4 goes to everything within the parentheses. So we could rewrite that as x squared times x to the 6th raised to the -4. So that means I'm going to multiply those exponents. So I'm going to have x squared times x to the negative 20th, negative 24th, which is going to be x, multiplying like bases, x to the second minus 24 is going to give me x to the negative 22. Continuing to simplify that to a positive exponent, we would find the reciprocal, which is going to be 1 over x to the positive 22nd. So there you have that simplified expression. Going through all the rules that we know, again, continuing to simplify until we have that positive exponent. We've combined everything that we can combine and have a positive exponent. So remember, looking at this next example, this negative 2 goes to that w, this 5/3 goes to that w, and this 3 goes to everything within the parentheses. So we end up with w to the negative 2 times w to the 5/3 times 3 over 1, which is going to be w to the negative second times w to the, it would be 15 over 3, but we can simplify that down to just w to the 5th. And again, we have w like bases, so we add our exponents, and that ends up becoming w to the 3rd. So again, sort of applying all the rules, as one student said, every time it's a different thing. Well, every time we're doing a little bit additional to it to show that we are expanding what we know. So simplifying a product raised to a power. Okay, so if we look at what is the simplified form of each one of these expressions? Okay, let's just look at what we know. The stuff inside the parentheses. We should know that that is 7 raised to the first power, and we should know that this 9 exponent goes to the m, and so that's what's inside the parentheses. And then outside the parentheses, we should know that this 3 exponent goes to everything inside of the parentheses. So that would be, if we rewrote it, it would be 7 to the 3rd times m, let me make it a little bit easier here, 7 to the 1st raised to the 3rd power times m to the 9th raised to the 3rd power. So we know then that this would be 7 to the 1st times 3 times m to the 9th times 3, which is going to give me 7 to the 3rd power times m to the 27th power, which 7 to the 3rd power, do some math real quick, which would be 49 times 7, which is going to give me 343 m to the 27th. There we go. Simplified that expression. Biggest thing here is we often forget that this exponent goes to everything inside the parentheses. Okay, so again, we know that inside our parentheses, that is 2 to the 1st and z to the 1st. This negative 4 will be applied to everything within there because it's a product. So we have 2 times 1 raised to the negative 4th, and then we have z to the 1st raised to the negative 4th, which again is 1 times negative 4. And, I know I'm showing a lot of steps here, but I want to make sure that we understand the math going on, and you don't just say, hey, where did that come from? So we have 2 to the negative 4th times z to the negative 4th, which, finding the reciprocal of those, because that is a negative exponent, we want it to be a positive, that would be 1 over 2 to the 4th times 1 over z to the 4th, which equals, that should be 1 over 16 z to the 4th. Okay, remember, we're working with reciprocals to find that positive exponent there. So again, applying gradually over and over again all the rules added together of what we've been doing. And let's see here again, looking at this next example, C, we have 3g to the fourth, all raised to the power of -2. So remember that is 3 to the first. So we would have 3 to the first raised to the -2 times g to the fourth raised to the -2. Power raised to a power, so that would be 3 to the first times -2, and this would be g to the fourth times -2, which gives me 3 to the -2nd times g to the -8. Finding the reciprocal, that would be 1 over 3 to the 2nd times 1 over g to the 8th, which simplifies to 1 over 9g to the 8th. Again, gradually doing what we know at each step. I showed a lot of steps, but if you write the step down, it will reveal your next item. Okay, so simplifying an expression with products. Well, what is a simplified form of each one of these expressions? We actually just did examples with products. It just happened to be only one set of parentheses. Well, the only difference here is that we have two sets of parentheses, but all of the information is still the same, or all of the concepts are the same. It is just multiplication. So zooming in here, we know that we have x to the -2 raised to the 2 power. So everything in there is going to be raised to the 2 power. Then we have 3 to the first power, x to the first power, and y to the 5th power. And all of those things are going to be raised to the 4th power. So when I rewrite this, I get x to the -2nd raised to the 2nd power. There's no change there. Times 3 to the first power raised to the 4th power. Times x to the first power raised to the 4th power. Times y to the 5th power raised to the 4th power. So we have x to the -2nd times 2. We have 3 to the first times 4. We have x to the first times 4, and we have y to the 5th times 4. So we end up with x to the -4th, 3 to the 4th, x to the 4th, and y to the 20th. And we do have some like terms here. We do have like bases that we can go ahead and work with. So we have x to the -4 plus 4, because we have like bases, we add the exponents. 3 to the 4th, y to the 20th. So this becomes x to the 0, which is also 1. So this would be, well, I guess I'll just show it. We have x to the 0 times 3 raised to the 4th is going to be 81 times y to the 20th. So again, this becomes 1, so we have 81 y to the 20th is our final answer. Final simplification. And doing it again here, we have, let me go ahead and do this. That became 1. So anything multiplied by 1. All right, so looking at B, again, we have 3 to the first power, C to the 5 seconds power, 5 over 2. 4 goes to everything within those parentheses. We have C to the 2nd power, and 3 goes to everything within those parentheses. So we end up with 3, 1 raised to the 4th power. We have C to the 5 halves raised to the 4th power. We have C to the 2nd raised to the 3rd power. So we have 3 to the 4th. We have C to the 10th, and we have C to the 6th. And this becomes 81 times C to the 10 plus 6, or 81 C to the 16th. There you go. Simplifying these expressions. Didn't show every single step that time, but you know what? We should be getting a little bit better at it. Raising a number in scientific notation to a power. This is simply substitution. Let's look at this, or evaluation. The expression of 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m, kilograms, traveling at a speed of v meters per second. Real quick, they've told me some stuff here, that v is my speed. They've also told me that mass is kilograms. What is the kinetic energy of an experimental unmanned jet with the mass of, looks like they've given me a mass of 1.3 times 10 to the third kilograms, traveling at a speed of, they've given me a speed of 3.1 times 10 to the third power meters per second. And well, it says, what is the kinetic energy? Well, the kinetic energy right here is from this formula measured in joules, so I can do some substitution. I have 1/2 times my mass times my speed squared, and they told me that my mass was 1.3 times 10 to the third. I have 1.3 times 10 to the third. And then they told me that my speed was 3.1 times 10 to the third. Okay, so I have 3.1 times 10 to the third. And let's see here if we do some simplifying here. I know that I have 1/2. And I know that I have 1.3. And I know that I have 10 raised to the third, and I got to remember here that this 2 goes to everything in this parentheses, so that should give me 3.1 squared, and I should have 10 to the third raised to the second. And all I've done is sort of just write some stuff out so you can see the process and the thinking that's going on here. So when I rewrite that, of course, I could have put it all in the calculator without a doubt, but it doesn't take a lot to do this. I have 1/2 times 1.3 times whatever that's going to be. Looking at my notes, came to 9.61 times 10 to the third times 10 to the sixth. So all of my numbers here, this stuff right here ends up becoming 6.25 times 10 to the 3 plus 6, which is equal to 6.25 times 10 to the 9th in scientific notation. And we have to remember context. 6.25 times 10 to the 9th is great, but it is going to be what? It asks what was my kinetic energy. So that is my kinetic energy. So that is joules. 6.25 times 10 to the 9th joules, which is a lot of joules right there. Let's see here. So what is the kinetic energy again? So they're asking me for my joules of an aircraft with a mass of 2.5 times 10 to the fifth, traveling at a speed of 3 times 10 to the second. So now we just go ahead and fill in our equation. We have 1/2 times 2.5 times 10 to the fifth times 3 times 10 to the second squared. So we end up with 1/2 times 2.5 times 10 to the fifth times 3 squared times 10 to the fourth. Continuing on here, we end up with 11.25 times 10 to the, right here, 5 and 4. So we have 5 plus 4, which is going to give me 11.25 times 10 to the 9th. But we are not in scientific notation right here any longer, so we need to make sure that we move our decimal place. So we're going to move it, left 1, so we're going to be positive. So it's going to be 1.125 times 10 to the 10th joules of energy. Okay, so there is where we end up with. Okay, so we have covered power to a power, and as we come over here and we look at our worksheet that we've been working on, our little note-taker guide, we are going to be looking here at, we've already, again, covered zero, our regular forms, our negative properties, our product rule, and now power to a power rule. Okay, so remembering when raising a power to a power, you want to raise a power to another power, you want to keep the base the same and then multiply the exponents. So that rule would look something along the lines of a raised to the b raised to the c is going to be a b times c, or simply a b c raised to the bc. So, and then giving you a mathematical example, we might have x to the third raised to the fifth, which would be the same thing as x 3 times 5, right? X raised to the 3 times 5, which is x to the 15th. So there we have some of the, in practice, what we have just gone over with this entire lesson, and we'll continue to fill this out. And I'm going to go ahead and, again, we have some information here that we have covered as we gradually fill in our note takers.